Welcome everybody to our ARC HPC at OntarioTech fall update for 2025. My name is Armin Shobani. I'm an HPC technical consultant based at Ontario Tech University. You can see my contacts here, my phone number at work, and also my room, and also the two emails. You can use them whatever you like, either my SHARCNET or OntarioTech one. And whenever you like, you can arrange an office visit for different things. For example, how to use our systems, installation of software, access to commercial software, and etc. There are other HPC technical consultants, residents in other universities. I don't know. I just send these invites for also Durham College. Durham College has a shared campus with us, and they are one of the institutions that are part of the SHARCNET. I can also do the same thing for them as well. So no problem. We are providing our services to all universities, but I am the one that resident at Ontario Tech. So we provide the same service for Durham College as well, if there are any, participants from Durham College as well. So in today's update, we will, show you first how you can find the previous recordings and also this recording when it's available. Then we talk about latest info about the hardware refresh, and we have a new cluster named MIBI. I'm going to show you some screenshots of it and some new features. Then we talk about the new and existing ways to access our resources. And because we are in the, rack season, and the application is now open, we will talk about how you can apply for rack and when you need to do that. And at the end, updates about our training courses and some Q&A at the end. So let's start with where to find previous updates. And, when we had these updates last, fall, I mean, in 2024, one of the most asked questions was, is it going to be recorded? And actually, we had it at the beginning today as well. So you can find the slides and recordings for previous sessions at this link. You can just click on it, or use your mobile to do that. I can also click, but one caveat about this is that because this is on SHARCNET training, I've already logged into this. But if you are not, when you first click or go to this link, it requires you to log in. But once you log into it, I think it's a problem with this content management system. It doesn't go to the link. It goes to your default page. So you should, after login, you should click on the link again to end up in this section, which is the recordings for OntarioTech University. This is slides and recordings for previous year or previous update. I'm going to, put the new recordings in the same place. I think after 1 or 2 days, they are going to be ready, and you can find them here as well. Because we have these things there, I'm not going to repeat all the things that we had in the previous update, and I want to focus on the changes that we have. So that being said, let's start with the latest info about the hardware refresh. But before that, because maybe we have some new users here that they are not familiar with these things. So let's start with this. In our campus or any other universities, it's the same way. Yeah, you have some academic and day-to-day computing that is usually supported by the campus IT system. So at OntarioTech, you can find it at this link, and you probably have the Gmail account with the OntarioTechU.net and those things. And this is for day-to-day computing, for example, uh, Word, Excel, and those things as well, and also your classroom. But if you have to do some advanced research computing or ARC or HPC, high performance computing, or maybe you are a librarian and you want to do research data management, or also you want some training on ARC, data science, machine learning, it's our territory. So you should come to us and we provide these kind of services for you at this link that you can see. So these are the two things, but there are three pillars of supercomputing or high performance computing, which are the HPC clusters, cloud services or infrastructure as a service, and storage. We provide all these resources for our users. So usually when you are working on your computer, you have access to the storage and memory. But when we talk about this kind of storage, it means that huge amount of the storage or a very large amount of memory in computers. We provide these kind of services for you. So in Canada, the resources and services for advanced research computing is provided by Digital Research Alliance of Canada through four regional partners, West DRI, Compute Ontario. I don't know if you can see my pointer here or not. Paula, can you, when I move it, can you see it or?
We can see it. Yes,
Yes, I can see it. Yes.
Okay, great. So the thing is that Calcul Quebec and AceNet, there are in total 5 different clusters here at WestDRI supported and by WestDRI, NIBI at SHARCNet, and Trillium supported by SciNet, Narwhal and Rorqual by Calcul Quebec. AceNet doesn't currently have any clusters. So these are the total number of clusters that we have. If you want to access all of these resources, the only thing that you need is to get an account with the Alliance, which is completely free. To do that, the only thing that you need to do is to connect to our CCDB, which is this link. You can use this QR code. Or if you want a step-by-step description of it and some helps, you can use this link instead. It's in the Alliance, and the latest documentation is also available on our documentation wiki. I'm going to show you. But one change that we have since 2025, April, is that the multi-factor authentication is now required. You can find more information about it, but the good thing about it is that it uses the same soft app to authenticate, which is Duo Mobile. So it's like the same that we use at OntarioTech. So you're already familiar with it. The only thing that you need to do is to also register your CCDB account with this so you can get the notifications when you log into our system. So now for both, whenever you log into our CCDB or also our clusters or any other services, you have to provide this MFA or a second factor as well. This is one major change that we have. These are the supercomputing resources, the 3 pillars that I mentioned. The clusters that we have, you can find their name and address: Sphere, Narwhal, NIBI, Rorqual, and Trillium. And these are our cloud services or infrastructure as a service: Arbutus, Beluga, Cedar, and NIBI. These names may be changed soon because these are some of them. NIBI, actually now the cloud is also changed, but for Cedar and Beluga, maybe later the name of the cloud also updated to the name of the cluster. But for now, it's the same as before. And the storage space, you have access to 3 different file systems on all of our clusters: home, project, and scratch. There are different caps or limitations for them. Some of them are regularly backed up, for example, home and project, but the scratch is not. You can find more information about these things on our documentation wiki. I'm not going to take much time in this. So one thing that is important is that at any time, because these are so dynamic, these services are at any time, maybe something happens and they may not be available. So the first thing that you have a problem accessing these services is to check our status page. You can find a QR code here and also the URL. I can show you here by clicking this. Here you can see the latest status of each of the clusters. So for example, if you have a problem, you can see that, for example, our previous cluster, Graham, is on end of service and is not available anymore, for example. But for NIBI, for example, you can see that there is a planned update of admin server, for example. And by clicking on this, you can find more information about that. So whenever, and it's the same for cloud services as well. So whenever you have a problem accessing them, the first thing that you should do is checking the status page. Here is our, our HPC clusters and storage after the hardware refresh. You can see that the only cluster that is still, not going through the hardware refresh is normal. So it's nothing changed about it. But the other clusters, they are all, changed to their successors. For example, for us, Graham changed now to NIBI. This is the successor to Cedar. You can see the number of cores and GPUs. You can see that all the GPUs now upgraded to H100. The only exception is for Narwhal, which is all the GPUs are A100 still, because it's the old cluster. And this is the amount of storage that you can find and the total amount. You can find all these informations on this link or this QR code. NIBI, as you can see here, has 36 nodes of NVIDIA H100 and 4 AMD MI300A that I'm going to talk more about this. One thing that you can see here is that most of the previous clusters are now decommissioned. You can see the dates. The only one that remaining is Beluga, which is only login. You can log in to manage your files or transfer them to the new the successor, which is Roar cluster. So these are the things that the information about our new clusters. But that brings us to our shiny new cluster, NIBI, which is built by HyperTech and hosted and operated by SHARCNET at University of Waterloo. NIBI is the Anishinaabe word for water. That's because, as you can see in this video, NIBI uses the liquid immersion cooling. So that's cool. And that's the, one of the reasons that we chose the name NIBI for our new cluster. Here are some new specs of CPU nodes. You can see that in total, there are more than 130,000 CPU cores on NIBI. There are some of them, most of them, 700 of the nodes have this amount of memory. 10 of them are for large memory simulations and those things. Each of them have 6 terabytes of memory. And their local storage, which is NVMe, is on each node. They have 3 terabytes of storage on each of them. That's separate from our storage, for example, the project home and those things. This is the node local one that during running your job, you can transfer your files there to experience more speed, for example. And these are the specification of the CPUs. All nodes are on a 200 gigabits per second interconnect, and all of the nodes have internet access. This is a change from our previous cluster, Graham, in which only login nodes had access to internet. Now all the nodes, including compute nodes and GPU nodes, have internet access, and there is no need for proxy or anything. That makes your life much easier, especially those of you that want to train for example, large language models and those things, or rely on some databases outside of our clusters. As I said, it uses liquid immersion cooling. You can see in these videos as well. And GPU nodes, we have a total number of 42 nodes. 36 of them are NVIDIA H100s, each having 8 NVIDIA H100, but each with 8 gigabytes of memory. 6 of them are AMD MI300A, which has a unified memory. The important feature of these 6 nodes is that they use a unified memory. So both CPU and GPU have access to same memory using the same speed, which makes them very interesting choice for some applications in science. But they are not yet available. They are already plugged in, but we are working to make the operating system available. It may happen in about next week or so. The same, like the CPU nodes, all of them have internet access, but one of the difference is that they use the direct-to-chip liquid cooling rather than total immersion. So you can see that there are some pipes delivering the cooling system to directly cool the chips like that. And the storage is now, we have a parallel file system from vast data. It's 25 petabytes, all SSD. Most of them are NVMe's, and it has much better performance and some features which is new to NIBI now. For example, if you now accidentally remove some of your files, there is no need to submit a ticket for that. You can just type oops, as you can see in an MOTD or message of the day when you log into NIBI. And then it shows all the recently removed file, and you can recover them if you like. And there are some other changes to management of file and folders for users in the project. You can find this information on NIBI page. For your information, we have also official NIBI launch event at the University of Waterloo this at the end of October 31st. At 10 to 11:30. If you are interested to have a close encounter with a supercomputer and see it from close, you're welcome to register. The deadline for registration is tomorrow, October 17th. If you're interested, you can just click on this link and register to be there at the end of the October to see that. But the new clusters have some new and exciting ways, to connect to them. one of the things that we have here now is open on demand. So that's what I'm going to show you how you can do that. So in the past, you all to connect to our clusters, you could use the SSH terminal or SSH client to do that, to first connect to login nodes, and then use our batch scheduler or a Slurm to submit your jobs to run on compute nodes. This is still there, no changes to that. There are different ways to do that. But the new thing is that now you can use the web browser and GUI or graphical user interface to do the thing. There are two ways. One is using the Jupyter Hub, which is available on all the clusters. But on two of the new clusters, which are NIBI, our cluster, and also Trillium at SciNet, there is also new service, which is called Open on Demand. You can use that one to do the same thing now. Maybe in future, other clusters also provide this service to you, but currently it's only available on NIBI and Trillium. So here, these are the ways that you can connect using the SSH terminal. I'm not going to talk about that much more, because you can find it in the previous recordings and also in our documentation wiki. The new thing is that we already had Jupyter Hub. If I click here, you go to the page in our documentation wiki that shows you how you can connect to Jupyter Hub on different clusters. You can see that NIBI is not there, nor Trillium, because now you should use Open on Demand. But one thing that we can do is that because we have the same interface now on Open on Demand to use the Jupyter Hub, we may update this link to also have NIBI here as well. Because you can actually do the same thing using the Open on Demand now. So this is the link for the Open on Demand on NIBI. You can just go to ondemandSharcnet.ca. If I click on this link, it goes there. And now you can see that we have compute nodes and login nodes. So this is the new thing that we have. Now you can also have a basic desktop to login nodes, or desktop on compute nodes, and also NIBI Jupyter Lab. So these are all available now. So for example, if I want to have a Jupyter lab session now, I can go here. You see this more or less the same interface like our Jupyter Hub things on other clusters. And you can ask the things that you want, for example, GPU and those things. But the good thing is that is now have all those your sessions can be there, and you can have them switch to them as you want. So if you go to my interactive sessions now, you can see that I've already opened a Jupyter lab, and it's already running. So it says that it's time remaining 2 hours and 19 minutes with 4 gigabytes and without a GPU. So the only thing that I need to do to connect to this now is to click on this. If I want to cancel it, I just click on this. If I click on this, it ends up on the same interface that you have on our Jupyter Hub thing. So you can go to Python and also VS Code and other things, and you can load the modules here. And if I just close it, it will be persistent there until the time 2 hours and 18 minutes finishes. then it will be destroyed. But once that happens, you can see the history of it here. So these are my previous sessions here. They are just there. If I'm not want to, keep them, I just delete this. But those that are already running, they are there. So you can just click connect to connect. I have the same basic desktop, which is also on login node, is already there. Uh, and if I want to switch to that, I just need to click on this to go to the desktop and start, for example, the terminal and running things here. And for example, you can see the module system is the same here. And if I want, I can close this as well, and then whenever I want to switch to that. But if you want to have a new compute node desktop, which runs on compute nodes, for example, using GPU nodes, you can come here and, for example, request for GPU. We have now MIG configurations as well. And if you like, you can enable virtual GL if OpenGL hardware, is necessary. And I can change this to 1 hour and 2 cores and launch. When you typically do this, it may take some time to allocate the nodes. So you can see that your session is currently starting. Sometimes it may depending on your previous use, it may take some time, but you can see that now it's launched and ready. So if I click on this is my desktop on compute node, actually the GPU node. If I open the terminal, you can see that it's a GPU node. Now we have new coding. So for example, all GPU nodes start with G, and all compute nodes start with C, and login nodes are L. So for example, if I go here and open my basic desktop session that I already have, you can see in terminal that it's L3, which means login node number 3. So this is the way that you can do it. And to run, for example, Jupyter jobs on using Open on Demand, now there are 2 ways to do that. You can go directly to NIBI Jupyter Lab here and have it like the way that other clusters doing it. Or you can have a compute desktop like this here. But in order, like the one that I allocated here, you have to prepare your Python virtual environment, for example, to install the Jupyter Lab in it. If you want to find how to do that, you just go to our documentation wiki here and go to NIBI page. So here you can see the information how you can do that. So the only thing that you need to do is that to pip install Jupyter Lab in your already existing virtual environment or new virtual environment. And then you can run the Jupyter Lab on your desktop after doing that. So that's the thing you can do. This is 2 different ways that you can run your Jupyter jobs on NIBI now using the Open on Demand. So that's more or less the thing. If you have more questions or concerns after this talk is over, you can also ask them. But the next thing that we have is connecting to cloud. Is not much different. Nothing changed here. Only some of the cloud services name, for example, NIMI is changed. You have, for example, this is good. For example, when you want to do inference only thing and you want to provide this service to other users, so you can have a persistent CPU cores for that and start to have a server there and get even the valid IPs for that and provide this service for others to use, for example. And for transferring the files, you can still use the Globus. You can find more information on our documentation wiki. And if you want to get more help, as I mentioned, all our documentation are now available on our documentation wiki, docsalliancescan.ca. And also, this is the SHARCNET website. You can find the Q&A sessions here. So I put it here, something that is changed from last year is that now we don't have new user seminar. We have a weekly Q&A session. In the training I'm going to show you, we have now the new self-paced module for new users and also the GPU. Some of them are becoming mandatory. For example, if you want to submit jobs that using the GPUs, once you finish those self-paced course, you can also get a certificate. If you have any questions, every Tuesdays at 2 p.m. you can go to this link or calendar and bring your questions and ask them with with us. We have also the ticketing system like before. For any problem that you have, you can submit it to support at techalliancecan.ca. And you can also directly contact us using email or phone using the, our about page in our website. As I mentioned, we are now in rack season, usually happens at this time of the year. When you first get your account, especially for PIs that have a new account with us, it's important to know that you have a default access there, that there is no limit in CPU and GPU cores, but you have priority. It means that after submitting jobs after a while, your fair share may be exhausted and then your jobs remain in the queue for more time. This is the default access thing. For computation, in terms of storage, you have 50 gigabytes in home quota for your home, 1 TB for the whole group in the project, and 20 TB on Scratch, and 10 TB in Niala. And these are the limits for the cloud. So there is no need to request anything if your needs are at this level. Using the same default access, which is also called rapid access service, you can also have access to a little bit more things. So for example, using the same thing, if you are on for example, deadline to submit a paper, you can submit a ticket and ask to bump up your jobs. So we can do it for, some of the, what I'm trying to tell is that it can happen once or twice, not frequently. So you should preserve it for the time that you really need it. But we can do that for you, so you can skip this, the waiting for some jobs that have a deadline. And about the storage, you can increase the whole, the project space to maximum 40 terabyte across all clusters. So for example, you may have 30 terabytes as 30 terabytes on NIBI, and then 10 terabytes on Narwhal. And that's it. You can't go beyond that. So these 40 terabytes in across the country or overall clusters. And for the nearline, you can increase it the quota to 100 terabytes. The only thing that you should do is to submit a ticket, and you can do it at any time. This is part of the rapid access service or RAS. But if you need more than this. So for example, you usually find yourself, your jobs are, sticking in the queue and there are lots of wait there. If your need is more than 200 core years for CPU or 25 RGUs for the GPUs or reference GPU units, or you need more storage than 40 terabytes for project or 100 terabytes on nearline, then you should apply for a rack award. So cloud, this is the same for cloud as well, but the name for it is there are two different types of racks that I'm going to show you. So this is the RAS versus rack thing. These are the differences between these two. We already had this thing. And as I mentioned, there are two types of rack: RRG, resources for research groups, and RPP, or research platforms and portals. So if you need cloud, for example, services, more than the things that is in RAS, then you should apply for an RPP. And if you need more compute things, you should apply for an RRG. These are the limitations. And for example, as I mentioned, if you need more storage, it must be more than 41 terabytes or more than 100 terabytes for nearline storage to be eligible for an RRG. So this is the thing. These are the important days for this year, the rack. The deadline is November 4th, and the announcements of results happens in late March 2026, and all the allocations will be implemented early April 2026. These are the info sessions already done. So if you miss them, these are the recordings. These are the links for the slides, and these are the links for the recordings. This is the general rack overview. This is for GPU requests, and this is for cloud requests. And if you want to do that, to find the guides about the rack, this year rack, this is the link for it. And this is the application form in CCDB that you can, if you want to apply, you can click on this. The last thing that we are going to cover is SHARCNET's online training. Nothing much change. We have intro to our courses. It's already started now. There are 2 1-hour classes each week, include lectures and labs. There are different topics. You can check our training site for that. And as I said, we have self-paced courses, SHARCNET self-paced, and you can find the list of all of them there in our training site. And these are the available courses. These are already there now. And we have a weekly Compute Ontario colloquia, the same Wednesdays at 12. And Compute Ontario Summer School, which has finished now, but for the next summer, it's going to be there. We will announce the dates. And this is the SHARCNET YouTube channel, which you can find all the recordings of these, for example, weekly general interest webinar or Compute Ontario colloquia there. And that brings us to the Q&A session.